Welcome to SOMA Academy. I'm Siad Malim, and today I'm going to show you how to construct a frequency distribution table. In this lesson, I will discuss how to create or construct a frequency distribution table. I will then find a pattern in the dataset using the frequency distribution table we created, and I will also create a histogram for the dataset. Let us say we have this dataset here. The dataset can mean a lot of things. For example, these are just random numbers, but it could also be a representation of data collected through surveys. Let us say this dataset is a representation of data collected through a survey in a refugee camp. 25 individuals have been asked the question, what is the size of their WFB food ration card size? The response could be 1, 3, 4, 2, 6, 7, 8. So any of this number. So what we want to do is we want to draw a frequency distribution table for this dataset. And in order to do that, a frequency distribution table is simply just drawing a table of the dataset. So let us say we want to draw a table where we have A here is ration card size. Okay, that is the ration card size. So, and the numbers in the data set, here, they range from 1 and the biggest number is 8. So we have to do that. So we have to draw 1, 2, 3, 4, 5, 6, 7, and then 8. And then on this column, we will have the frequency. The frequency is just a fancy word for count 8. Okay, looking at this data set here, we have to count how many times did 1 appear. How many times did 1 appear? So I see 1 here, 1. I also see 1 here. So there's 1 here, there's another one here. So how many times did 1 appear? That is 2 times. Okay, so we do the same for 2 also. How many times did 2 appear? Let us say there's 1, 2, 3, 4, 5. So 2 appeared 5 times. Okay, 2 is 5 times. And then we continue like that. How about 3? How many times did 3 appear? 3 is 1, 2, 3, 4. So we have how many times? 3, 4 times here. What about 4? Okay, what about 4? We have 1, 2, 3, 4, 5, and 6. So 6 appeared, 4 appeared 6 times. And then we continue. 5. How about 5? Okay, 5 is 1, 2, and 3. Okay, so 5 is appearing 3 times. Then we do 6. Okay, how many times did 6 appear in this data set? 1, 2, 3. So also 6 is 3 times. For 7, what about 7? 7 is just 1 time, I think. And then 8 is also 1 time. So 7 is 1 time, 8 is 1 time. But one thing that is very important is that after you do this, you always have to sum up the frequency distribution column, because what you want to do is the sum of this should be equal to how many data sets you have here. We have here 25 data set. I've already counted 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5. So you have 25 data set. So when you add the frequency column, you also have to get same number, 25. So 2 plus 5 is 7. 4 plus 6 is 10, so that is 17, 20, 23, 24, 25. Okay, so that is the same. Normally we say that 25 is usually represented by n. N is the sample size of the data set. Sample size. So this variable n is always a representation of the sample size of any data set. Okay, so now we have our frequency distribution table. It is very easy to identify any patterns. Say, for example, we could say which is the most popular answer. What is the most popular answer? Most popular answer. The most popular answer is the one with the most frequency. So 4, ration card size 4 is the most popular answer. And what is the least popular? So the least popular, we have 2 here because there's 1 and 1 here. So the least popular are both 7 and 8. The second most popular answer is 5, because so that is ration card size 2. Size 2 is the second most popular. Okay, so when you have the data set in this form here, when you have the data set in that form, it's very hard to easily respond to these questions, like what is the most popular answer, what is the least popular answer. But when you have frequency distribution table, it is just easy to get the answer right away by looking. And the essence of having a frequency distribution table is basically to help any individual who is looking at that table to easily identify the answers they are looking for. The answer. Okay, so let us draw with this frequency distribution table, we have to draw a histogram. Okay, and in order to draw a histogram, let me say these are my axes. Usually when you are drawing a frequency distribution table, on the x-axis, this is the y-axis, on the x-axis is always equal to, okay, the number of, in our example, ration card size or ration card size. Okay, you don't even need to write the number of. So it is here is ration card size, and here is what you have frequency. Okay, so that is the frequency or the responses. Okay, so here we would have, what is the scale? We have to have a scale then. So this is 1, 2, 3, 4, 5, 6, 7, and then 8, because that's what we have on as the number of the ration card sizes. Okay, and on here we can have 1 up to. From this frequency distribution table, the least is 1 and the highest number here is 6. So we can say from 1 up to 6, or you could even say 2, 4, 6. But let us just say 1, 2, 3, 4, 5, and 6. Okay, so 1, 3, 4, 5, 6. Okay, so what is the answer for 1? How many people responded to 1? So it is 2. That is, you have to draw the bar like that. And then for the responses for 2 is 5. So always in a histogram, the bars must touch. The bars must touch, and I will explain why after I finish. Okay, so and then for 3, the responses was 4, because that is 4 here. Okay, the bars, the width of the bars must also be the same. Okay, yeah. And then for 4 is 6, which is the most popular. Okay, this the bars here are not exactly right because I'm not using a ruler or anything, but they should always be the same. Okay, the scale is not accurate. So 5 is 3. The response is 3. 6 is also the same. Okay, 7 is 1, and then 8 is also 1. So that is your histogram. Histogram, the bars should always touch. The bars should always touch because the data values, when you have the data values as numerical, then the bars must always touch. But if they are categorical, for example, the color, like color or male or female, anything of that nature that's categorical, the bars will not touch. And in that case, when the bars are not touching, it's a bar graph and not a histogram. But for histogram, they should always touch. And so once you have frequency distribution like this, it is very easy to draw the histogram. My histogram is not the most beautiful one, but you get the idea. So I hope you found this helpful. I will stop there for today. Please do not forget to subscribe. Until then, happy learning.